In this online session, we'll discuss statistical process control. So when we monitor a process, we want to find out when a process is in control and when a process is out of control. Potentially, we could make two types of errors. So one, when the process is in control, we end up taking corrective actions. So this is a mistake we call type 1 error. It is at the producer's risk. On the other hand, when the process is out of control, we don't do anything. We do nothing. So this is second type of error. It's called type 2 error. This is at consumer's risk. So neither error is good. We want to avoid both type of errors. So how do you do it? So we need a formal way to determine when a process is in control, when a process is out of control. So that's all we want to talk about, statistical process control. We need a formal tool. So how do we know if the service process is performing as expected? So in other words, the process is in control. So how do we tell if performance variation is a result of random occurrence or has a specific cause? So for example, if we talk about bank, so how long it takes to help a customer make a deposit. So we can anticipate there could be some variation. Sometimes it can be 3 minutes, sometimes it can be 4 minutes. Even if we use the same bank teller, we can anticipate that the exact amount of time it takes to help each customer will not be exactly the same. There's always some kind of variation. So this type of variation is called random occurrence. It's purely random. It's natural. It's it's expected. But some other time, the variation can have a specific cause behind it. For example, one day we hire a new bank teller, and this bank teller is not well trained. He has no experience. So we can imagine if we hire such a bank teller, the amount of time it takes to help a customer will be much longer. So when we see this type of variation, we know the variation is caused by a specific cause because now we have a brand new bank teller with no experience. So the question here is we want to tell the difference. Sometimes it's a purely random, sometimes it has a specific cause. So how do we know? That's why we talk about statistical process control. It's a formal tool. So we are going to discuss two types of control charts, variable control charts versus attribute control charts. So what is variable control charts? So variable control charts includes X bar chart and R chart. So when you see the bar here, typically bar in stats, it means average, mean or average. So X bar chart and R chart are called variable control charts. And remember, X bar chart, R chart always used together. So I don't do X bar chart separately. So these two charts we have to do at the same time. So we use X bar chart and R chart to measure variables on continuous scale. For example, length, weight, or time. So if the process performance can be measured in terms of length, weight, or time, we can use X bar chart or R chart. This is called variable control charts. A second type of chart is called attribute control charts. We call P chart. We use P chart to measure the presence or absence of some key quality characteristics, such as percentage of failure, percentage of defective products. So for example, if you look at the performance of specific class over a semester, we look at how much percent of students fail the class. So this semester, we can have 5% students fail the class. Next semester can be 10%. The following semester can be 7%. So we look at the percentage of failure. So when in such a case, we can use a P chart. We'll talk about percentage. So once again, for the variable control charts or X bar chart or R chart, we use these charts to measure length, weight, or time, continuous scale. And then we use P chart to measure percentage. Now, first of all, let's look at the variable control chart. We'll look at a specific example. So remember, when we use variable control chart, we use X bar chart and R chart always the same time. So here we're talking about the performance for emergency ambulance. So we want to look at how much time, what is the response time for any incidents. So what we did is we collect a sample on each day of the week. So this is day 1, day 2. We collected 1 sample on each day. So each sample contains 4 data points. So these 4 numbers are the 4 data points. This is a 1 sample. Each sample has 4 data points. And that's why we say a sample size is 4, because 4 data points for each sample. So this is a 1 sample. This is a 2nd sample, another sample, another sample. So if you look at table, we collected 7 samples, and the sample size is 4. Okay, so we have 4 data points in each sample. So each number represents the response time for a particular incident. So for example, the last data point in sample 1, it takes how long? 4.9 minutes. Okay, that's the response time. So with all the data collected, how do we construct X bar chart and R chart? There are 4 different steps you need to follow. Step 1 is to calculate the mean. So what is mean? Mean is X bar. So X bar is mean. And the range is R. The range is R, and mean is X bar for each sample. So I have 7 samples. We start with sample 1. Okay, sample 1. Look at sample 1. For sample 1, I need to compute 2 numbers. One is X bar, what is average? Other one is R, what is the range? So range is defined as a difference between the maximum and the minimum. So first of all, for sample 1, let's look at the average. So what is the average X bar? So average, we take average. We use 3.6 plus 5.2 plus 6.5 plus 4.9 and divided by 4. So this is talking about average. Average is 5.1. So we calculate average for each sample. Next, we want to calculate the range. So range for sample 1. So how do we calculate range? The range is defined as a maximum, the difference between the maximum and the minimum. So what is the maximum for sample 1? Sample 1, the maximum 6.5. So what is the minimum? The minimum is 3.6. The difference is that 6.5 minus 3.6 is 2.9. So that is the range. So we have the mean, we have the range for sample 1. And we need to do this for each sample. For sample 2, the mean is 6.2. Take the average of these 4 numbers. And the range is 2.7, which is basically the difference between the maximum 7.2, the minimum 4.5. We will continue the process. We do this for each sample. So altogether, we have 7 samples. So that is step 1. Calculate the mean and the range for each sample. Step 2, calculate the mean of X bar. Okay, pay attention. This is mean of X bar. So X bar is the mean of the mean. In other words, we're doing the average of the average. Okay, we're taking average of the average. Same time, we want to compute the mean of R. Okay, in other words, R bar. So what is the average of the range for all samples, namely X bar bar, double bar. So X double bar means take average of X bar. R bar means take average of R. So this is step 2. So first of all, let's calculate X double bar. So these are X bars. So all these 7 numbers are X bars. Okay, these are the X bars. Now I want to calculate X double bar. So X double bar is defined as the average of the average. So that means X double bar is the average of these 7 numbers. Okay, these 7 numbers. So 5.1 plus 6.2 all the way to 4.3 divided by 7, because I have 7 numbers. I have 7 X bars. We have 5.0. So this is the X double bar. We also need to compute R bar. So R bar, we can see R bar is the average of all the R's. How many R's we have? We have 7 R's. So we take average of these 7 numbers. So R bar is equal to 2.7 2.9 plus all the way to 2.0 divided by 7. We'll have 7 R's. So we have 2.6. So this is step 2. So step 1 is calculate X bar and R for each sample. Step 2 is calculate X double bar and X R bar for all the samples. So now we move to step 3. Step 3 is just to construct the R chart. So we start with R chart first. So how do we construct an R chart? An R chart needs 2 numbers. We need an upper control limit. We need a lower control limit. So how do we calculate upper control limit and the lower control limit? We have formula, which is D4 times R bar and D3 times R bar. So R bar is clear. So R bar is from step 2. So what is D3 and D4? D3 and D4 can be found from table 6.7 in the textbook. In the test, the table will be provided. So this is the table. So we can find the value for D3 and D4 from this table according to sample size. So for example, in this particular example, what is sample size? So because every day we collect 4 data points, that's why sample size is 4. So this is sample size. So according to the sample size, we can see the corresponding value for D3 and D4. So in this case, we can see D3 is 0, D4 is 2.282. So that is the value. So once we know the D3, D4, we can calculate the upper control limit and lower control limit. So which is D4 times R bar, D3 times R bar. R bar is from step 2. So we can do the math, we'll get 0 to 6.0. So this is the R chart. So for R chart, we need a lower control limit, we need the upper control limit. Now we have both control limits. Step 4, we want to construct the X bar chart. So how do we construct X bar chart? So we are going to calculate the upper control limit and the lower control limit using the formula. So it will be X double bar plus minus, we have upper control limit, lower control limit, plus minus A2 times R bar. So we know R bar, we know X double bar. These 2 numbers are from step 2. So what is A2? A2 is from the same table according to sample size. Again, in this example, sample size is 4. So that's why we can see A2, the value for A2 is 0.729. Then we can plug in the values. Plug in the value for X double bar, which is 5.0, R bar 2.6, A2 0.729. We do the math. We get the upper control limit 6.9 and lower control limit 3.1. So step 3 and step 4, now we know the control limits for both X bar chart and R chart. So now we're done with constructing the charts. Then we can monitor by using these charts. We can monitor the process, okay, by taking samples on a regular basis. So you keep taking samples on every day, taking 1 sample every day. Once you take a sample, we calculate the sample mean and sample range. We calculate X bar, calculate R for each sample. Then for R, we compare the value of R with the upper control limit and lower control limit. We compare the value of X bar with these 2 control limits, upper control limit, lower control limit for X bar chart. So if a sample range or sample mean is outside the range, okay, we have upper control if it's above the upper control limit or below the lower control limit, we say the process might be out of control. That's why we may need an investigation to find out what is a possible reason. Okay? So if the sample mean and sample range is within the range, is within the control limits, then we say it's fine. We don't have to do anything. But on the other hand, if the sample mean or the sample range is above or below the control limits, then we may need to do something. We need to do investigation to find out the possible cause. So this is just a graphic representation. So this is an upper control limit. Here we'll talk about X bar, okay? Mean response time, X bar. So this is an X bar chart. We have an upper control limit. We have a lower control limit. So on each day, we take a sample. We calculate the sample mean or sample average, and we plot it in the control charts. So you can see day 1, day 2, day 3, all the way to day 9 is fine because these sample means are between upper control limit and lower control limit. But on day 10, you can see sample mean falls above the upper control limit. That means day 10 signals the need for root cause analysis. So we may need to do something to find out what are the possible causes. So this is about the variable control charts.